Hi, this is Miss Escamilla, and I'm going to show you how to get started on your homework this week. It's due Friday, January 13th. The biggest thing that I want you to remember when doing your homework is to be labeling the answers to your problems. I really want you to get comfortable with interpreting numbers, but not just those numbers, what those numbers actually mean and represent. So make sure that you're thinking about the labels that I've given you and how those relate to the answer you get when solving the problems. So if you're tuning in, you're going to be lucky because I will actually be giving you the answer to the first problem of each day's homework. So if you're watching, you get a little extra help. So thank you for tuning in. So let's go ahead and get started. I'm going to switch the camera. All right, so this is what our homework looks like this week. And on Monday's homework, the requirement is that we divide using the standard algorithm and then label our answers. So if you notice, the first problem that I give you, or the example that I give you, is 93 pencils and 6 pencil bags. So you have to think about how pencils and pencil bags would be related to each other. And what I know is that usually we put pencils in pencil bags. So if we have 93 pencils and we can put 6 pencils, and we have 6 pencil bags, then we're probably going to be needing to find out how many pencils we are going to be able to put in each pencil bag. So we're going to divide using the standard algorithm. We're going to go ahead and do 93 divided by 6. And the first thing I'm going to do is I'm going to take the number 9 and divide it by 6. So I know that 6 can go into 9 one time without going over. Then I'm going to multiply 1 and 6, and I get a product of 6, and I subtract that 6 from the 9 for a difference of 3. I then bring down this 3, and I've created a new number that I want to divide. I've made 33, and I want to divide it by 6. So 6 can go into 33 5 times without going over. So I'm going to put a 5 up here. Then when I multiply 5 and 6, I get a product of 30. I then subtract those and I get a difference of 3. I don't have any other numbers to bring down, so that 3 is what I actually have left over, or what I call, and what we've called in class, a remainder. So it looks like we have 15, a quotient of 15 with a remainder of 3. And because we're talking about pencils and pencil bags, we could say that we could put 15 pencils in each bag, and there's going to be 3 leftover pencils. So I'm going to label that 15 pencils in each bag with 3 left over. Okay, so really focusing on interpreting those numbers and what they mean. So that's an example for Mondays. Now on Tuesdays, the directions state to multiply using the standard algorithm and to label the answers as well. So in the example, we have 57 bananas in 8 baskets. And so when I stop and think about how those two things are related to each other, I know that we can put bananas in the baskets. So if we're multiplying these two numbers, what we're trying to find out is how many bananas there are all together in all of the baskets. Okay, so using the standard algorithm, I would multiply 57 times 8. And using that standard algorithm, that means I would take 8 and multiply it by 6 for a product of 56. Put my 6 here, carry my 5. Then I'm going to multiply 8 times 5 and get 40. Add the 5 that I carried over for a total of 45. Okay, and so I'm going to label this. I know that 456 represents the number of bananas that we have all together in all of those baskets. So I'm just going to simply label bananas. 456 bananas. Okay. On Wednesday, we are needing to find the sum. And I noticed that when I'm looking at the problems that we have decimals. And we also, again, have to label our answers. So addition's kind of easy. because you can't really add apples to oranges. It's kind of like adding apples to apples or oranges to oranges. So the labels are going to remain the same. So if we have candy and we're adding more candy to it, then we're going to end up with some more candy. The trick to adding decimals is to kind of make decimals look like money. We want our whole numbers, a decimal point, and the numbers in our decimal positions as well. And so I notice in our example problem we have 12, which is a whole number, represents 12 whole pounds of candy. And then we're going to need to add that to 3 9/10 pounds of candy, which as adults we kind of refer to it as 3.9 pounds of candy. In class, the mathematical way to pronounce that would be 3 9/10, because that 9 is in the tenths place. Because we have a whole number that we need to add to a decimal, we want to make our numbers look alike to make them easier to add. And sometimes making it look like money is usually what I think seems to make the most sense. So I'm going to take that 12 pounds of candy and I'm going to make it look like money, or turn it into a decimal by adding a decimal point after the 12, a 0 in the tenths place, and a 0 in the hundredths place. So it kind of looks like $12. And now I can take that 3 9/10 or 3.9 and I can align that. We have to make sure that we line up those numbers correctly. So I'm going to put my 3, which is in the ones place, right underneath the 2 from 12 that's in the ones place. I have that decimal point that I need to line up with the decimal point above it. And that 9 is in the tenths place, so I'm going to put it directly under the 0 that I put in the tenths place. And then I'm going to go ahead and add a 0 in the hundredths place to make it, again, look kind of like money. It looks like $3.90. So now that our numbers look more uniform and our decimal points are lined up and we have numbers in each our tenths and hundredths place, it makes it a lot easier to add up. So I'm going to go ahead and add those, or find the sum of these two decimals. I know that 0 and 0 make a sum of 0. 0 and 9 make 9. Bring down my decimal point so that they're all lined up. 2 and 3 make 5. 1 and 0 make 1. So I end up with 15 9/10, or we could refer to that as 15 90 hundredths. And we were adding candy, so I'm going to label it pounds of candy. And that is the sum of the example problem from Wednesday. Again, I remember to label it. All right, on the last section, on Thursdays, we are going to be subtracting to find the difference. And again, we need to label our answer. Labeling and subtraction is a lot easier as well. So, for example, on our sample problem, 30,000 Pop-Tarts and 4,407 Pop-Tarts, we could kind of assume that, you know, maybe those Pop-Tarts were being eaten, or maybe they were thrown away, or maybe the Pop-Tarts got destroyed, you know, and so they're going away. So we're going to interpret that, and then so that we can label it. And if we're starting off with 30,000 Pop-Tarts and we're eliminating 4,407 Pop-Tarts, that means the answer we get is going to be labeled Pop-Tarts, because that's going to be the amount of Pop-Tarts we have left. But be really careful when you get to the other two problems, and you're really going to need to analyze the wording on it, because on the second problem, we're starting off with 200,000 songs that we need to download, and we've already downloaded 80,469 songs. So I'm thinking the question needs to be, well, how many songs do we have left to download? And then again on this last problem, be sure that you're paying attention to the labels that I've provided and interpreting them correctly. All of these problems are requiring us to what I call subtracting across zero. 30,000, 200,000, 40,000, 100, lots of zeros in the larger number. And so that makes it a little bit trickier to subtract, because we have to regroup over and over again. But I'm going to give you an example. So if we start off with 30,000, excuse me, let me fix that so it's a little bit neater. and I subtract 4,407, I need to make sure, first of all, that you are lining up those numbers correctly. Notice how I line up my ones place with my ones place, my tens place and my tens place. The hundreds are together, the comma is together. That represents the separation between our thousands and our ones. And so our thousands place is lined up, and our 10,000s place is lined up. And then I'm going to draw my little line across. So one of the things that a typical mistake that kids make at this age is when you are starting off with a smaller number on top and a larger number on bottom, is to just simply flip-flop those numbers to make it work. But that's not okay. Flipping those numbers will only give you a result that is incorrect. So I always tell my kids, I always tell you guys that you can't take 7 away from nothing. So you would want to borrow from your next door neighbor so that you're able to subtract. But I noticed that we can't borrow from this neighbor because he doesn't have anything to share. You can't borrow from this neighbor because he doesn't have any to share. Can't borrow from this neighbor because he doesn't have anybody to share. So you got to go all the way down to the far neighbor at the end of the street over here to borrow some numbers so that we can actually subtract. So we would borrow from that 3, and if we have 3 of something and we borrow 1 from him, well, that leaves him with 2. And we give that 1 that we borrowed to his neighbor. In front of the 0, I put a 1 to give him that 1. We regroup there, and now he is actually a 10 instead of a 0 now. Which means because he's a 10, this neighbor can now borrow from him. So if this neighbor borrows from him and he was a 10, he's shared 1, now he's a 9. And that 1 that he borrowed goes right in front of him. Now this 0 can borrow from 10 because he has some now. He is 10. And if he shares, then he's now left with 9 if he shares 1. And he becomes a 10. Now our first person over here in line can borrow from this 10 because 10 has some to share. Then 10 lends him 1, he's left with 9, and this 0 becomes a 10. We get to put a 1 in front of him. So we had to regroup quite a few times. And now we can subtract. 10 minus 7 is 3. 9 minus 0 is 9. 9 minus 4 is 5. 9 minus 4 again would be 5. 2 minus 0 is 2. And then I count 3 places over. 1, 2, 3. And that's where my comma goes. So the difference is 25,593. Okay. So thank you for watching the video and tuning in. I hope that this was able to help you a little bit. If you have any questions or you get stuck on something, make sure that you can have your parents email me or call